Alright, today we're going to outline the reasons for greater ozone depletion in the polar regions. In other words, when you watch the news and they're talking about the hole in the ozone layer, it always seems to be above the North Pole. Well, there's some reasons for that. The world weather and wind patterns concentrate or carry the CFCs and nitrogen oxides into the polar regions. And then in the wintertime, it's actually sort of segregated away with weather systems that circulate around the polar region. And so there's not as much opportunity for all of these concentrated pollutants to actually exchange and go back into the rest of the planet. This is visualized very, very well in a documentary called Earth from Space. If you ever get a chance to watch it, it's fantastic. Now, during the winter time, so we've got all these harmful CFCs and nitrogen oxides here, and during the winter there's 24-hour darkness, and during that time it's very, very cold. Ice starts to build up. And ice surprisingly acts as a heterogeneous catalyst. Ice is solid, and then all of our pollutants here are gases. So they actually are catalysts for the formation of chlorine molecules, specifically from the chlorofluorocarbons. And when that happens, we can see what might actually happen later, and you might be able to draw a couple connections to other topics in IB chemistry. So in the spring, lo and behold, the sunlight comes out. And the presence of the increased amounts of pollutants leads to greater destruction of the ozone. As we could see earlier, light is actually very essential for some of these processes to happen. Additionally, the sunlight reacts with the chlorine molecules created over the winter, like we just talked about, from the catalyzed reaction on the surface of ice. That actually creates the chlorine radicals. And we actually saw this free radical mechanism when we looked at how we would turn alkanes into halogenoalkanes. So that same step where you need light, UV light, to actually have that homolytic fission. Well, it's spring, the sunlight's back, and we create all these chlorine-free radicals. And then in the previous outcome, we actually looked at how that could, those chlorine-free radicals can actually react with ozone. So all of those connections together, we can actually see that we get a lot of greater destruction of the ozone, not only due to the concentration, but due to the fact that it's accumulated in the darkness and then the light comes, and that's when a lot of these processes start to happen.